So let's do one more step, and that is now I've created this little function called counter loop. Okay. So what we do inside counter loop is we declare a variable called count, and then we keep decrementing it until it reaches 0. So while count is greater than 0, count minus 1, and the moment this is done, we'll break out of the loop and go back to main. And of course, main loop is still a while loop, so we are going to increment x, then run this counter loop, which is basically going to take 10 iterations of decrementing this count, and then we come back, then we increment x and so on and so forth. So basically, we have slowed down the rate at which x increments by adding about 10 instructions or 10 counts, 10 increments down here. So that's basically the idea. Let's see what is happening to x and what is happening to this count variable when we compile it. So you can see that there is basically this problem, which is this counter loop has been declared implicitly. It says, when the compiler is reading this, it comes to counter loop and says, okay, I have no idea what counter loop is, and you know we don't know what this is. So to fix that, to ensure proper good C practices, we are going to declare this function up here. Okay, so the compiler knows that this exists. Then we're going to use it, but we are going to define it later. Okay, so let's do a clean, and then let's do a build. Now you can see that that warning is gone because we have declared it properly and then defined it later, so no problem. Now we are going to go and now we're going to say debug. So let's go and debug this. So programming, we are getting flashed. There we go. So this is the start of our main function here. This is our main that is starting. What is the first instruction? First instruction, as expected, is to make x 0. Okay, so we are going to make x as 0. And now you can notice that we are not using R0, we are using a different register called R4. So we have said, let's go back here. So R4 is now being used as x, x is 0. Then we are going to branch, we are going to jump to this counter loop, which is out here. Okay, so now when we come to this counter loop, which register are we using? We are using R0, and we are loading it to value hex A, which is integer 10. Okay, so value is hex. Let's number format, we can change it to decimal if you want. So this is 10. So what is the next thing? We are going to we just did a check. Is this branch is equal, right? So we're just checking if we got 0 or not. So now we are going to decrement this. So sub s r0 r0 1. So this should cause this to become 9. So it becomes 9. Now we are going to do branch if not be any branch if not equal, and then we are going to go back here. So let's see. Okay, so now we go back here, subtract, and so on and so forth. This continues. Okay, so what you can see is, you can remember our counter x. Okay, we started off with 0, we incremented it 1, so we made it 1, and then we have gone to this function counter loop. So if you probe x and see what is going on here. Okay, so this register variable stores in x. Let's see what is going on with register x. You can see that this is still holding x value. Okay, so R0 is getting decremented, 4, 3, 2, 1. Okay, and then now the subtract has happened. It has become it will become 0 now. Step into. Oh, sorry. We used it as count greater than 0. Okay. Uh, so then count greater than 0 should have, where will we end up? Okay. We incremented this. Then R0 became this again. Right. So now the next step should be this will become 0. Branch if not equal. So this is CL2 and it should jump to the label CL2. Okay. Uh, Only if not equal. So now, because this loop has ended, so we are going to go to the next line, which is going to be this dx. So that is this one. Okay. So now this is coming back here. This is basically your branch return. Okay. So we have returned and we ended up here. So now go here, increment Rx, and then call the loop again. So that is how register variables are being used. Okay. So we'll stop debugging here, and next thing we'll do is basic GPIO.